Dr. McCabe got here. So.
Okay, did you have a background in music coming into this sort of music technology? Did you know much
I started out as a musician, been playing my whole life, and got into audio technology in high school. Sort of as a hobby, more of anything.
You did it on your own? Did the school have anything to offer for you?
Not really in school. I had my mentor is actually a big recording studio guy up in Atlanta. And so he sort of got me into that. He went to my church, and so I sort of got into it with him.
Very cool.
And I still hook up with him a lot, borrow gear from him from time to time.
There you go. Yeah, well, it's expensive. All this gear is. They have a mixing board, and then all of the filters and effects and everything else.
Absolutely.
What instruments do you play?
I play a lot of different instruments. My primary instrument here, which I'm doing a master's degree in performance, I'm actually a euphonium player, which is sort of like a small tuba, if you've ever seen it.
Okay.
But I play all kind of stuff. I play bass. Played bass on some records that I produced, and guitar, piano, everything pretty much.
Okay, so you got a home studio or a home setup in some ways?
Yeah, it's weird because I started out doing that with the home studio, and then me and Dr. McCabe sort of built this studio when he got here. And so I do most of my work out of here, not really in my home studio anymore.
Like what software actually do you use? If you,
we have a Pro Tools system here.
Pro Tools.
But we also have Logic and all the kind of stuff for all the students to work on.
I was going to ask Matt about this, but maybe you can help. I mean, say a student like yourself comes into the program, really wants to learn something about the tech side of music.
Sure.
What kind of courses? What's the program of study? What does it look like?
Yeah, we just started an audio technology program, which is sort of an emphasis in audio technology along with the music degree. So it's a bachelor's degree in music with emphasis in audio technology. So students can take classes ranging from basic recording techniques all the way into more electronic music, which is sort of Dr. McCabe's specialty.
Okay.
He writes electronic music. Which is basically using computers to create music. That's sort of the layman's terms.
Right, I got it.
But yeah, it's all kind of courses are offered, and you don't have to be an audio technology student to actually partake in the courses. In fact, we have lots of students that are just regular performance majors or music education majors that take classes in audio technology, because technology is being used in just about every field of music nowadays, not just in the recording business, but music educators have to know a lot about technology as well. So a lot of students are taking these classes. So as an elective.
Right. Well, sounds great. Hey, thanks for talking to us.
Absolutely. Yeah.
So, do you guys know about polar patterns?
Like on the microphones?
Yeah.
Like the cardioid patterns type stuff? Well, just a little bit.
That's probably the first thing to get really familiar with and solidify in your mind. The problem that you're having with bleed over from the lavs is that lavaliers tend to be omni.
Picks up everything.
So
right.
And this can either be done on a switch on the mic, depending on what kind of mic you have, or electrically it will do it as a result of the construction of the capsule. So if this is the sound source, or this is the center of the capsule, and the microphone is pointing this way, and you can imagine this is a 360-degree sphere, what this means is that it accepts, theoretically, 100% of the frequency response in all directions. These are of interest to us because we use them to mic in the concert hall, right? If you're recording the orchestra, you take two of them and put them left and right, so you have two ears, and do it sort of that way. As you go down, the rear of the microphone will change how much it accepts, like how much frequency it accepts. So you know that we have, so this is omni. This microphone has rear rejection. So anytime you see cardioid, right, the Latin word for heart, it looks like an upside down heart shape. And then you can get it even tighter and tighter and tighter, all the way down to shotgun, where if this is the capsule, you get this weird, like, straight ahead thing. Those are the ones that you see, like the guys on the sidelines at NFL games that have the dishes.
Right. Yeah.
And you hear the crack of the helmet or something like that. They're standing there like that. So this is actually, there was a bunch of video equipment purchased here maybe 6 or 8 years ago, and this is one of the things that they bought, which is a camera mount shotgun microphone. So this is what you're looking at as far as.
We use that anytime we do
Right.
video interviews. I generally use a
Yeah, we'll mount this on top of the camera, and you just do this.
You just aim it, and so the range, how wide, how close do the people have to be? Is that
They don't
something
really have to be
adjustable
that
or?
close, but they have to be pointing right at the mic because
Yeah.
it's very directional. Just
Okay, because imagine the further you get back, maybe the wider the pattern might be. And some of
Well, yes and no. The other thing which causes problems is proximity. I can spell. And I'm sure you guys have experienced this, that the closer the microphone is, the fuller it sounds,
more bass.
right.
and you get more mids and more bass in the speech region. This is particularly pronounced with dynamic microphones, like the ones that you might be considering buying for the tabletop.
Mhm.
So the classic, and I'm sure everybody's seen these before. The 58.
Right.
This really is only useful if it's here,
Okay.
and you'll see the singer sort of back off of them, and when they go up into the higher register because it's louder. But we wouldn't use this for any kind of ambient miking. Like you wouldn't put this on top of a camera. It just doesn't push out enough signal to be clean like that. So what that leads you to is using condenser mics,
Okay.
microphones that are powered. And I mean, I have a whole lecture that I give my classes on the difference between dynamics and condensers. But these are the mics that are using phantom power or a battery pack like your clip-on lavs. The problem with that is that they're omni. So for your tabletop panel thing,
Mm-hmm.
I think solving that problem would either come from using booms
Right.
and getting them out of the frame,
Right.
or doing the David Letterman thing.
The mic right here
No,
Or-
on the
or-
desk.
on the desk right at you.
Because the condenser microphones will have less proximity effect than the dynamics. So what you might do is, and this is, there's all sorts of, this is about $400 mic, and these actually belong to me, but I love them. So, you could take this, and this is the front of it, and you could put it on the desk like this in front of your anchor or whatever. And you could even get it out of the frame. But as they're speaking, right, you get the best sound when you're pointing at the source.
Right.
So even a lav right here, you're still getting a lot of throat and no direct, nasal
Oh,
implosives
absolutely.
and stuff like that.
And one of the little things that we've learned just recently is where to put the mic, because if two people are talking and we mic the person, or we let them put the mic on, they'll put it over here,
Right.
and then they'll turn to the person
Right.
away from the mic, and we totally lose the sound in
what
just that short amount of time or distance.
You know what I might do is, and this kind of mirrors the process that we use for capturing concerts. So let me actually just open up something that we recorded last night. It was Paul Vinecourt's
Okay.
percussion thing. So we tape typically 4 channels in Legacy Hall. If it's a bigger concert, and depending on what kind of sound we're looking for, we'll put up more mics further back to get more of a room sound. And then sometimes we'll actually put what we call spot microphones or accent microphones right in front of the source.
Okay.
So here, we actually, this is the piece of Vinecourt playing last night. So this is just what's hanging on the ceiling. And the wood blocks were maybe 8 feet away from the left tight microphone that's hanging from the ceiling, and you can hear the wood blocks sound very present.
Right.
Whereas the woodwinds are further away, so they sound farther away.
So, which of these is that mic that we're hearing?
You're hearing 2 omnis hard left and right, and 2 cardioids that are like this.
Okay. Okay.
So like on David Letterman, so David Letterman would have a mic underneath his desk, and then what about the guest? What do they have? Like, do they
A
have?
lot of times they have lofts,
Yeah, they'll have lavs on.
usually.
But the end of that thought is that I've got, so when he's playing the vibraphone, there was a microphone on top of the vibraphone. for a very direct sound.
Right.
And what we'll do as part of this whole process of producing the concerts is that the students or me or Philip will come in here and we'll actually mix it in the box, which is, you know, and I know you guys you aren't doing that right now. You're going straight to tape through a board, but you can still do it. You know, if you're monitoring right over headphones or something like that, you can get it right. What you might want to do is add a more omnidirectional microphone that's further back, or a cardioid that's further back. So in other words, you've got the lavs on and you're mixing those in, but then you have a camera-mounted cardioid that's pointed at the conversation.
Right. All right. So yeah.
The idea being that we can take both the focal thing that's very close up and the ambient thing that's sort of capturing the whole event and balance them to get what we want. Yeah.
Or maybe a third one too, by the way.
When you get to the next step, what you might want to do is mirror what we do, and that's record every single mic. We don't mix anything during the recording process, unless we run out of channels, which we have to do for like the jazz band and stuff like that, where we go, okay, well we have 6 drum mics and I don't have 6 extra channels, so we have to boil those down to 2.
Well, see, Seiji has talked about that in the past. We've had this discussion, but there's so much bleed over. It's not just separated. Like the time I came in here before, you had the guy I don't know if Philip or somebody, but with the bass guitar, you had an amp in another room, and a mic on an amp in a completely different room. So it's totally separated.
Yeah, and that's sort of how we do it in the studio. But bleed's not necessarily like a really bad thing. I mean, as long as you can control it. I mean, a lot of times we'll do live sessions in the studio where you still hear bleed. Like you have a sax player playing with the drum in like the same room. You can hear the sax in the drum mics, but it's not necessarily like a really bad thing as long as you can kind of control it.
Right, it might be actually good so you match things up a little bit. You've got like a
It's more about keeping the whole thing balanced.
Right.
And you know, actually, we took the Popular Music Ensemble out to do the Armstrong show. Have you seen this? Out at the NBC
you told me about it in an email, I think.
Yeah. So we were on there and we showed
Dan's
up.
a big fan.
Yeah,
When you say trim,
I think so.
Well, let's pause for a second.
Okay.
Come up here for a minute, please. I need to see what you guys are familiar with.
Do you mean like the game? Like,
Trim and game are very
that's
similar.
another question.
Pretty
though.
much the
okay,
same
yeah,
thing.
there's a terminology
Pretty much the
too.
same thing.
Yeah.
A lot of times consoles have both a trim and a gain.
Starting with the lavalier mic, like the transmitter has, you know, you can go in there with like a little screwdriver and change the gain, which we never have. I don't even know if those are all the same. And then, you know, that runs into the wireless receiver, which also has a volume knob, and then that will run into the mixer, whichever channel, and that will have this gain setting here.
Yeah.
You know, and then we have this level here.
That's not necessarily a bad thing.
Okay.
This trim, right, or gain knob, is, you can look at it as how much am I pulling. And actually on older mixers you'll see this labeled as pull.
Okay.
So what you're doing is changing the impedance of that input so that this, as you turn it up, it resists less when the signal's coming in. So this is a mic preamp, is basically what it is.
Okay.
Once you get into the channel strip, this doesn't add any gain unless you go above unity. Faders are for just that; they're for fading, or the other word for this is an attenuator, is to turn it down.
Okay.
So your wireless mics, you want to run them at unity, which is where they're not adding any gain at all.
Okay.
Of course, with radio-based things, it's going to be kind of weird anyway. But I would do the trimming here,
Okay.
where you set up the trim level on the mixer to come in. And do you guys have those Sennheiser packs? Is that what they are?
They're sure.
Sure.
Ours sort of auto gain. I don't know if these have batteries in it, but these are actually really great quality. And you can see that this meter just will not clip. I mean, if I blow on it, it'll clip. But this is transmitting as much as it can reliably from this capsule. I'm not sure exactly how it does it. But I would put the receiver on that and then turn it up from there, from the board. Just so, you know, if you turn this up, you're going to put gain on all the noise too.
Right. That makes sense. All right. So yeah.
So like instead of the volume from the receiver that goes into the mixer from the mic, do we want to turn that volume up like as high as we can without clipping? Is that like the idea? Is that what we want?
Yeah.
Do you have meters on your mixer?
No, we don't. We just have, it just tells us if it clips.
Yeah, see
okay.
that's a big problem, and actually we have that too here when we use this for recording. Is that we don't have the meter bridge that goes up here that shows you the input level of all the channels.
Right.
So you can.
What we kind of rely on is then the computer will show it.
The computer will show you the level. Yeah.
Yeah, I mean, but that's coming after it comes out of the mixer into the
Yeah.
computer.
So what you want to do is get that signal as hot as possible without clipping. So if you have, say 3 mics and you're doing an interview, what I would do is start off with one, and on here we have an output meter. Analog here, you don't want to go probably above +10, which is deceptive because in the computer, the top level that you can do in digital audio is 0, and everything else is negative. So, I mean, you can see, just to use this as another example, right here when the orchestra gets really loud, right, that's getting pretty close to clipping. That's the kind of signal level you want to see in when it's going into the box to be matched up with the video signals from your audio chain. And it becomes a very interesting craft to get it so it's not going to clip.
Right.
I mean, unless somebody goes, or something like that, then you might know to do
And
it.
they do, by the way. This this morning.
We can also give you some tips to help that as well.
I was doing it. I was recording this morning, as a matter of fact, and I had one hand over on the change cameras and do the things and pull up over there, and the other hand was on the mixing board with the faders. In this case, just trying to watch out because occasionally they'd laugh, and it just you can see it in.
Dialogue is really common, and so that's a big problem too.
That's where the compression comes in.
Okay, right.
Yeah, and that's something that we have just ordered for our board is a compressor, or going to today.
Yeah, an outboard compressor.
Right, compressor limiter on that, and so we probably have some questions about how to best use that as well. So
there's a lot of different applications for that. Do you guys know the fundamental way that the compressor works?
Yeah, I do.
Not really.
Actually, this is the way that I teach this, and this won't necessarily help you learn how to use an outboard compressor, but it'll get the concept right. So let's actually compress this channel. Okay, so this is getting pretty hot, and we want to control that. So say you can use this as an analogy. So this is your regular speaking level, and that's your laughter. So this compressor that comes with Pro Tools is actually, it kind of really sounds awful, but it's good for teaching it because it shows you the curve. An outboard compressor is not going to show you that curve. All this is a diagram of the input signal over the output signal. So right now, if this was an equation, your equation would be y equals x, right? It's a one-to-one thing. There's no compression. See? So what you want to do is this part. See, that's the current level. But when we get up to this level, that's what we want to control. So this knob, the threshold, in a digital system is going to go up to 0, and then you turn it down. The analog one is probably going to go to +10 or maybe even hotter. There's actually one in the rack right there that we'll look at in a second. But you want to get that threshold down to, I don't know, the rule of thumb, like halfway.
Yeah, about
In a 6 dB range.
So between the maximum and what's acceptable.
Yeah, kind of figure a window that you want to put it in, depending on how much compression you want. For single voices or a group of microphones that people are speaking into, you can use more compression, and I would actually go for that. When the students do little radio pieces here, and that's where we talk about compressions on one single speaking mic. Especially because your material is going through little tiny computer speakers and television sets and stuff like that.
Right.
Is that you want that dynamic range to be really, really tiny.
Yeah.
You don't want to have somebody whispering and have it be really quiet so that you can't hear it.
And
You know?
lockers
That's
really
why
loud.
politicians
Yeah, and
get
it just
caught on
goes off.
microphones all the
Yeah,
time. It's
that's
because
all.
everything is just compressed all to heck, and you can hear what they're saying. So if I set the threshold here, see, it turns red when it goes above the threshold. So I set a ratio of how much I want to turn it down when it goes above the threshold. So if I make this, say, 2 to 1, you can see the curve start to change.
Mm-hmm.
And what it's going to do is, this means gain reduction. So every time that signal goes over the threshold, it's going to turn it down. You can think of it as an automatic fader that sits there and goes, uh-oh, I'm getting real close to going over my threshold. I'm going to do this. And it does it very fast. So in this situation, I might want to go down a little bit further. And it's controlling the So if you listen to the difference, this is with it, this is without it. A little bit more punch to it. The point of the compressor, though, is the pickup gain. Is that if we smash this, right, and this is what the kinds of ratios you're talking about for speaking voice, where it's really... Now my output signal, if I put 3 dB of gain on it, start clipping.
Mm-hmm.
So you want to control that. Let me open up a different session here and just. I wonder if I still have my train essay on here. Yeah. So we have our little podcast. So this is going to mirror more what you guys are doing. But let me play you the original signal and show you what I did to it to get it to sound like that radio, type of compression. So here's my voiceover track. One of the first things that I noticed when I came to the Schrobe School of Music to teach music technology is that there's a pretty active rail line that runs right next to our building down 9th Street here in Columbus. Okay, so this channel, really we should talk sometime about how to get your audio separated from the video so that you can sync it up later.
Yes.
Because if you got, you can buy an audio interface with Pro Tools 9 for less than $500 right now. And you just have a separate computer, and you can use your mixer to send each channel out into the recorder so that if you don't like the sound that ends up on the tape, you can go back and fix it.
Yes.
So I'm EQing this, right? Just plain old digital EQ plugin. I roll off everything below 125 because this is not in my voice. If there's a particular part of the frequency spectrum that you don't need, get rid of it.
Because it becomes noise at that point if you leave
it modulates the signal
right
in those lows, and that's where you're gonna get like low frequency interference from the air conditioner and
which you don't want to just clean it up.
But at the same time, you want to leave the highs intact, especially for voices. So if I roll off the highs, one of the first things that I noticed when I came muffled.
Mm-hmm.
So you want to leave that in. One of the first things that I noticed when I came that's your intelligibility region.
Okay.
The S's and all the high consonants.
Right.
So we EQ'd it, and then here's that same compressor. One of the first things that I noticed when I came to the Schrobe School of Music to teach music technology is that there's a pretty active rail line. It's by itself. Down 9th Street here in Columbus. Experiencing that train going... So if I take the EQ and the compressor out... One of the first things that I noticed when I came to the Schrobe School of Music to teach music technology... It's kind of muffled. ...is that there's a pretty active rail line that runs right next to our building down 9th Street. We very opened up the top end to push that... Experiencing that train going by several times per day reminded me of the classic quote from composer John Cage. The compressor adds a little bit more meat to it.
John Cage. That's who we're talking about today. We're walking along. Just thought that name, I knew I'd come back to, but he just mentioned. That's great. All right.
Now the let me see how I did this. Oh, okay. There's a secondary. This is a limiter. So I've turned the limiter down 10 dB and set its margin at -0.1 so that it will go up to -0.1 and will not clip. The limiter will not let you go past that level. So you can see my speaking voice. One of the first things that I noticed when I came to the Schroeder School of Music to teach music technology
So is it compressing it if
is
it goes
that
over,
there's
or
pretty-
is it just not playing
it's
it?
not allowing it to go over at all.
So
It
the
will
difference,
infinite gain reduction.
the difference between compression and limiting is really limiters are basically a compressor with like a 10-to-1 ratio or higher. So basically, if you looked at the curve like it was in that other compressor, the curve would be flat. Instead of doing like this,
Mm-hmm.
it'd be straight up flat. So if
Well,
you, if
it
you
would
change
look
it
like
to
that.
10 to
What's
1,
the,
it'd be like that.
What's
Okay.
the difference between like limiting and like when they say like brick wall? Like
That's
Brick
pretty
wall, a
much
brick wall
limiting.
limiter
Yeah.
is infinity to 1 compression, so like that.
it will not let it go over.
You know, and in my experience, when we've really, and Seiji's done this with some software on some really bad audio, trying to just get it in some shape or form to make it happen. It sounded very canned. I mean, it was as if they were just crushed down so much to level out these audios.
We can actually do that. One of the first things that I noticed when I came to the Schroeder School of Music to teach music technology is that there's a pretty active rail line that runs right next to our building, down 9th Street, here in Columbus. Experiencing that train going by several times per day reminded me of the classic... That's what the audio at WTVM sounds like. On the
All the
New York
time.
show.
All the time.
It's just ridiculously overcompressed.
Right. That's what folks
So
get
you
used
can
to,
see, I
and
mean,
they
I'm
think it's a
smashing
standard.
this as 95 to 1, and I'm adding like 12 dB of gain to it. You're much better served adding the gain during the analog stage, and then compressing the master.
Okay. So you think for say for like for dialogue and stuff, we should just do compression for like the master track? You mean instead of like the
Yeah, I would
individual-
use your compressor off of the master out of the mixer.
Okay.
So let's actually patch in. You want to? Can you get 258s out?
Sure. So we'll put them on 23 and 24.
Right, so like a lot of problem that we have is that after it comes through the mixer, when it goes into our computer, it just goes into one channel. We just have like one master channel. So even though if we have like a show with like a three-person dialogue, what we end up with in the end.
It's all mixed together.
Yeah, it's all mixed together. So when we in post, if we do have audio problems, it kind of makes it difficult. Yeah, like if one person's mic goes out or something like that, like it's kind of hard because.
Yeah.
I mean, do you think it would be worth it for us to try to investigate, like you said, to get the audio routed into like a computer or something, so we could have separate channels or something like that, or
As a safety, definitely.
Is that typically-
unless you want to get really into getting the settings right on the board before you go into the box. You could do both though. That's what I'm saying is that.
Yeah,
You know,
that
what do
might
you
be
think
the
is
way to go.
typical
Just
setup for like say like daily lighting or something like that. Is that what do they do?
well, I
separate
mean, on a
channels?
much larger scale, yeah. They're multi-channel recording, all that stuff.
Right.
For a show like that, though, that goes to air like 3 hours after it's made, my guess is that they're doing most of it live
Okay.
because they just don't, they don't have the time to.
Well, that's kind of where the situation that we're in, and we only have like 3 employees basically, and like
Yeah.
we have a very
Yeah.
big turnover rate, and that's
yeah, and there's a lot of pressure to get something done in the
Right.
moment. Talent will come in and they're ready to go.
So I
and
mean, we always shoot for to get it as pristine as we can and do minimal amount of like post production. So,
Yeah. Well, I think that should remain your goal, but having the backup
Mhm.
where you record each mic individually, especially on a nonlinear sort of digital recording computer,
Mhm.
would be really helpful. If it's really bad at the end,
Mhm.
you can go, all right, well, we got to fix this in the in the box, and then we'll move the
Yeah,
audio.
then we have
over.
the option at least.
What would you do about something where if you're recording separate audio and then it doesn't sync up necessarily to the video?
You have to
Is
go
it-
into the video and move it around until it
Yeah.
lines up.
Well, I mean,
oh, is that?
if it's like
Here.
like sometimes the audio can be even a little bit faster than,
That's a sampling rate problem.
yeah, it's like a,
Yeah.
Yeah, that's why, and another reason to keep it analog as much as possible. is that, and we have this problem now because we have to change sampling rates for NPR. So sometimes the students will forget to change the digital converters.
When they're editing.
So if you have a session in here that's at 48 kilohertz and you're playing it back at 44.1, it sounds a minor third lower. Alright, hold on that for a second.
And you're probably running into problems because video is usually recorded at 48 kilohertz, as most recorded sounds like in 44.1. So if you do that, then it'll be. It's basically the same problem that we were running into with the NPR stuff.
Okay, so let me set up a just so that something that will be like what you're looking at on your inputs.
Oh yeah, another quick question I had. Do you think like in talk shows and stuff? Oh, I'm sorry. Do they like subtly pan people's voices at all? I mean, so say if you have like David Letterman on the right and the guest on the left, do they
Usually
do
not,
that?
because a
Yeah,
lot
no.
of TVs are in mono. So if you do that, then
I think that's going to change though. The more people are getting the bigger screen TVs with higher quality sound in the home.
Yeah, then it's fine.
Then it's going to be more.
But a lot of people have mono TVs, so.
So we'll create a stereo input. So we'll say that this is like, what you guys are doing. So here, and I think, well, actually I have to push these buttons on here. Okay.
Check.
So right now I've got no EQ coming into. So we've got two mics, and you guys could do this same process with the wireless or whatever you want. But here I've routed them into the computer on 1 and 2, just not to get too much into like putting the mixer in. But what you're looking at on the other end is very similar. So right now that's not great. Right, that's
Check.
even if I scream into this, it's not going to be very high. Is the meter colored on the input?
Yes.
Like you can see it.
Yes.
So
Green and then
you want to get it as close to 0 as you possibly can without clipping. So I want to add gain on this mic until I'm talking and it Okay, so now we're clipping. So that might be a pretty good trim level. So I know that these two mics are the same level, so we'll do it like that.
Check.
Now for speaking voices, you have an EQ on the board.
Mm-hmm.
So this EQ is actually a little bit weird because the highs are here and the lows are here, and then the two mid parametrics are above them, which is fine. We also have a low cut switch, which, like I said before, I mean I don't think I could sing 60 hertz, much less
No, yeah.
speak
It's
it.
probably beneficial
So
for you guys
we
to
can
do that.
cut out all the lows,
For all speaking.
and we know that. If you want to add a little bit more air, right, that clarity, turn up the highs, sort of get yourself trained a little bit with listening to frequencies. And I've got a great book that I just bought that I'll let you take a look at before you leave. That's actually an ear training program for audio engineers. So without even listening to this right now, I can tell that I've got a pretty good output signal, right? See, I'm getting up pretty hot. The computer, we've got a good signal coming in. So if you talk at the same time, if you talk at the same time as me, we're still not clipping, right? It's not a one-to-one adding thing. 1 + 1 does not equal 2 because of the phase cancellation. So we can both speak right now, and we're getting pretty hot. However, so hey Phil, how you doing? Ha 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 ha. That's not good. So what
we
we
have
can
those people. They come in the studio all the time.
yeah. So on our patch
Cough
bay,
really loud.
as you guys get more and more evolved, like we can come out and help you sort of try to build a little rig like this. But
Love it.
we put these in last year, and it's just been absolutely incredible. So while I'm talking through this, can you plug this in? It's not plugged in. And I think it needs a power cable.
Where are you plugging it into?
It's- it's-
cable,
What's that? Power and the sound.
Okay, and so your compressor limiter, I see you've got it set up the way you want. What's the general recommendation?
This is
setup?
set up for something else, so we'll go through each of the knobs.
Okay.
So what I'm going to do is I'm going to interrupt that output signal. And you guys may at the beginning end up doing this like right next to the board.
So this is the output of the mixer, you mean?
Yeah, the
Okay.
channels that I'm sending into the computer, now you can see that it's not there anymore. I've interrupted the signal in the patch bay, so I'm going to send it into the compressor and then loop it back.
Okay.
The reason why we do it like this is that replacing this is much cheaper than replacing that. So we don't move any plugs on the board ever. You can see I plugged the 2 mics in on this panel. We built this panel, and this panel costs about $20. If I had to go in and replace a plug on the mixer, that would be a lot more expensive. So we're removing all the wear and tear on the plugs on the board and putting them on individual pieces of equipment.
All right. So are there any extra cables back here that I should use?
Yes. The top bay.
Yeah.
It should be the 3rd out. DB25. It's channels 1 and 2.
So like input 17 through 24.
Yes. So 17. No. Output 17.
Okay.
Oh, wait. I'm sorry. It's on the bottom.
Yeah, it'll be on the bottom for the input. Just need to figure out where that's at.
I'm pretty sure that it's these.
Yeah, you're probably right because there's no other ones that are open.
And they're brown and red, right?
Yeah, it should be like just 1 and 2.
Yeah. So I'm sending this signal into the compressor here, and then I'm going to take it and send it back its outputs. So in essence, what we've just done is taken the master out from the between the board and the computer and stuck a compressor in the middle of it.
Gives you so much more control, as you said.
Yeah, there we go. Okay, perfect. So here, let's move this thing out of the way.
We have a lot more outboard compressors, by the way, in Studio
Yeah,
Theater for live sound.
we can walk over there and
In
see.
fact,
if
we
there's
took that
anything
out
on
of there so we can show you guys.
Okay.
This
Cool.
doesn't even live in here.
Yeah, I've asked for 2 more channels of compression. So this does 2 channels, and you always want to keep things left and right. So we can actually link them together so that the 2 channels receive the same amount of compression. This is stereo couple. Now this has a gate on it too. For us, if we're doing live sound stuff, we use the gate to prevent feedback. But because you're not amplifying anything, I wouldn't worry about that. So the gate. As I turn this gate threshold up and down, you can see that that's the gain reduction right there. So right now, when there's no signal going through, it's closed, and you get nothing. But let's not do that for now. So you can see here, I'm going above the compression threshold, which is probably a good thing. So we'll take that and we'll go maybe a 4-to-1 ratio. We want it to attack very quickly, and then we have an output gain. So right now we're bypassed. Let's engage it. And did you plug the outs in?
Yeah, it should be.
I'm not getting back into Pro Tools. So as things get louder, ha 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 ha, we get some gain reduction going.
Is it 1 and 1 and 2 and 2? Is that what it is?
No, it's 1 and 2 and 1 and 2.
Okay, then it should be right. That's right. If those are the right cables, because I mean, there's just a mess of cables back here.
Well, I'm getting the signal in.
Yeah, I know.
Check. Here, let me take a look at it
So
real
the
quick.
2s aren't working.
No, we're getting the signal in. It's just not going back out again.
Right. Yeah, these are the 2 ones. It's brown and red on both of them. Unless any of these cables is part of it. That should be it because they should be the same color. once you get your compressor and everything, you're going to be doing this troubleshooting.
Got it. No, we do quite a bit of it now. I tell you, one of our problems is that we just have to really start rerouting and running cables
Yeah.
and doing the things we need to do.
It makes things easier, but I mean, it doesn't matter who you are, what kind
It's
of
gonna
engineer
be
you
a-
are,
it's gonna
you're
be
be
a
troubleshooting.
well-
we troubleshoot all the time with signal flow. So
Yeah, we've got Matthew and I talked about this. We've got power cables and audio cables and video cables all together running,
Right.
and we've got to at least do that much to separate.
Yeah, we have
Right,
like
yeah.
enormous fire hazard running below.
Fire hazard.
Jungle
yeah,
wire.
you definitely
Jungle.
don't want like power cables running over audio cables. And
No,
whatnot,
it doesn't
you can-
sound like a
you can
good idea,
transmit
yeah.
what you sound
If you
like.
have to cross a power and audio
Right. Yeah,
data,
remember Matthew was telling me, cross them.
So as long as you do that,
That's
it's
on 'em.
fine.